The scariest legend from Norse mythology, Ragnarok, could have been inspired by true events. Yeah, that story where Thor and the other deities go down fighting and the whole world ends, only to start later again. Around the mid-6th century of the current era, two massive volcanic eruptions took place on the American continent. These eruptions sent huge amounts of gas and sulfur dioxide into the air, which made the climate much colder across the northern hemisphere, including Denmark. In old records from China during those times, they wrote the sun got dim and cold like the moon. Grain crops couldn't ripen properly, and stars were hidden for over a year because of the volcanic particles that still lingered in the sky. Scientists wanted to understand how this colder weather affected trees, so they studied the growth rings of Danish oak trees from around that time. They wanted to see how the shift in weather patterns affected tree growth during this period. The scientists compared tree samples from Denmark with ice core samples from Greenland. These ice cores hold layers of snow and ice that trap tiny bits of sulfur and other particles from past volcanic eruptions, so they can show when these eruptions occurred. The tree rings show that the trees grew less than normal in the middle of the 6th century, so the weather was much colder than usual, probably because of volcanic ash in the sky. Some farms were abandoned during that time, and nature began to reclaim these areas. All this may have caused big shifts in society, like changes in village structure and ritual practices. Archaeologists have also found many valuable objects buried during that time. It looks like people were trying to offer them to deities to bring back the sun. They feared that an endless winter before Ragnarok would start if they didn't do something. A long time before that, in what is now England, people were busy building Stonehenge. There's no debate that the larger stones were brought there by humans, but there's a new theory about the smaller so-called blue stones. They don't seem so blue on a sunny day, but they do have a bluish tinge when rain falls on them or you break them, so be careful. So the main theory is that our Neolithic ancestors worked hard to bring the stones from the Preseli Hills to Salisbury Plain. A new study suggests that long ago, during the Ice Age, glaciers might have used the Bristol Channel as a highway to move rocks. They found a large unusual rock called a glacial erratic in Limeslade Bay. A glacial erratic is a rock or boulder moved from its original home by a glacier to a new place. The rock in Limeslade Bay is made of a type of stone called dolerite, which isn't found in the Bay Area. But it matches rocks from North Pembrokeshire, which means it likely traveled by glacier to its new location. A massive glacier from the Irish Sea must have picked up this huge rock in Pembrokeshire and carried it southeast, then east, right up the Bristol Channel. They also found other glacial erratics along the Bristol Channel, which only supports this idea. So, if the new theory is correct, it means that Neolithic people didn't carry the bluestones to Salisbury Plain, but found them already there and decided to use them to build Stonehenge. Now, if you don't like shopping lists, try thinking of them as historical documents that someone will find, say, 3,500 years from now. Archaeologists in a region of Turkey that was known for the production of pottery, metal, and glass found one shopping list that was this old on a clay tablet. It's roughly the size of a large postage stamp and was made by people who lived in Mesopotamia. They used a very old type of writing called cuneiform, which means wedge-shaped, as it was made up of marks that look like wedges. The language written on this tablet is called Akkadian, and it went extinct long ago. They used sounds to make words, just like we do today. To write these sounds, they borrowed symbols from an even older language called Sumerian. The tablet itself is a kind of shopping list left by people who were buying a large amount of furniture. They mention tables, chairs, and stools. This record helps us understand how people in the late Bronze Age kept track of goods, money, and trade. Looks like they had an organized system for buying and selling things. Meanwhile, the Bronze Age shopping list is a youngster compared to what is thought to be the oldest calendar in the world. It shows the fall and impact of a comet from around 13,000 years ago. The carving is part of the Göbekli Tepe temple complex in Turkey. Talk about alliteration. It has large round stone structures and pillars that are carved with pictures of animals and symbols. People in the Neolithic period, around 11,000 years ago, built the temple, and it might have been used for something like a giant observatory for watching the night sky. One of the most interesting objects at the complex is a tall carved vulture stone. This stone has the image of a bird and other designs on it. One scientist who studied it thought the designs might show constellations. The carvings could tell the story of a huge comet that changed the weather patterns on Earth and caused a mini ice age. There are small V-shaped marks on the pillars at Göbekli Tepe, which could be used for counting days, and other stones could show big celestial events, like meteors or comets passing by. Archaeologists in Italy, near the ancient city of Naples, were checking the ground to change the city's water pipes when they found a tomb that is about 2,000 years old. It had been well preserved, with paintings on the walls that show scenes from myths and ceilings that haven't faded. This tomb of Cerberus was named after the most famous painting you can find inside. Cerberus was a creature from Greek mythology, a huge, scary dog with 3 heads. He was known as the guard dog of the underworld. One famous myth you can see on the walls of the tomb is the story of Hercules capturing Cerberus as part of his 12 labors. As the archaeologists kept digging, they discovered images of ichthyocentaurs, creatures that were like a mix between a mermaid and a centaur. The tomb also has a large altar with vessels for liquids that they would pour out as an offering to honor the deities. The person who was buried here lies on a decorated burial bed, surrounded by paintings, symbols, and objects that people in ancient times believed would bring peace or help in the afterlife. The tomb was just found in October 2023 and is not open to visitors yet, as archaeologists are still studying it. Scientists have long wondered how heavy stone blocks were carried to the sites of the pyramids in Egypt, and they might finally have an answer. Researchers from the University of North Carolina, Wilmington, believe that the ancient Egyptians built 31 pyramids along an ancient branch of the River Nile. It's now hidden under desert and farmland. It's not a new idea, but up until recently, scientists weren't sure of the location, shape, size, or proximity of the waterway the pyramid builders could have used for transportation. This time, they used radar satellite imagery, historical maps, geophysical surveys, and sediment coring to map the river branch. A major drought and sandstorms likely buried it thousands of years ago. The team managed to go below the sand surface and get images of some hidden features thanks to radar technology. They found hidden rivers and ancient structures running at the foothills of where most of the ancient Egyptian pyramids lie. Thanks to this discovery, we can now understand why they decided to build so many pyramids between Giza and Lish in what is now an inhospitable area of the Sahara Desert. These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams' alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano, so that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic Basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, Or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news. It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nadir crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nadir crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event. This time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA is keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700. But still, it's a reminder that Earth is always in the cosmic firing line. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest a storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
A trip to Hawaii may become your last. This is exactly what happened to David Potts, who came to Maui to spend some quality time with his girlfriend. We all know that the ocean can pose a whole bunch of dangers. Riptides, sharks, poisonous algae. Even a seemingly safe sand hole can end your life in a matter of seconds. Blowholes can do that too. The thing is, they're not frequently spoken of, therefore, many people just don't know that they'd better stay away from them. Now, let me break it down for you what a blowhole is. You all know sea caves, right? As any other formation, these grow in size. In case they grow landward and upward, they sort of turn into vertical shafts, exposing themselves toward the surface. As of now, everything seems fine, no extreme danger whatsoever, right? But the scary things start if those shafts begin getting hydraulic compression. In this case, seawater is released through a port right on top of the blowhole. The result looks like a geyser, and by the way, those blowholes even have a second name, marine geysers. The height of the spray may vary, and it's up to the geometry of the cave and blowhole, combined with tidal levels and swell conditions. So what exactly happened to David, who met his early demise in Hawaii? Those who were unlucky enough to witness this horrible incident said that Mr. Potts had been spotted dancing around one of those blowholes. He was dangerously close, just inches away from the opening. Moreover, some people claimed he had even been playing in the sprays of water that were shooting high into the sky. Then he suddenly disappeared into thin air. As it was discovered later, he fell into a blowhole. There were no official statements concerning whether Mr. Potts had passed away or not, yet he was never found, meaning his destiny is pretty much clear to everyone. The story took place back in 2011, so he's definitely not coming back, sadly. The big question is, who's responsible for this tragedy? There are no warning signs at the sign, so David could not know how dangerous that innocent fun was in reality. Moreover, witnesses claim it was slippery there, so it must have been an accident. However, despite most tourists knowing how notorious this area is, they still continue visiting the site. No tragic reminders help. So, how do you save yourself in case you come across a blowhole? The best way to do that is to keep as far away from it as possible. If you get sucked by it, your chances of surviving are virtually nil. Just for comparison, not every tsunami gives you chances this low. For instance, a 1-foot water level tsunami only gives you a 0.01% probability of passing away. Even a 3-foot water level, when you literally cannot stand on the ground, only says that the probability of passing away is high. Blowholes, on the contrary, don't give you any chances. They pull you in once and for all. But how do these terrifying holes actually work? Blowholes are most likely to form in places where there are crevices. A good example of a crevice is a lava tube. A lava tube, or you can also alternatively hear the name pyroduct, is a natural channel created by the movement of lava from a volcanic vent when it's traveling beneath the solidified exterior of a lava flow. When the lava within the tube drains away, it results in the formation of a cave. Those tubes can often be found along fault lines. A fault line is a flat fracture in the rock where significant displacement has occurred due to rock movement. Major faults in the Earth's crust are caused by tectonic forces, often forming at plate boundaries, like those found in subduction zones or transform faults. The rapid movement of these active faults generates most earthquakes, although some faults may shift slowly without causing seismic activity. It's known as a seismic creep. The next ingredient is powerful waves. When they hit the coast, water gets in those crevices. But since there's high pressure inside, it bursts out in the form of spray. To be honest, it's a whole show, as those water bursts are accompanied by a particular loud noise, which makes it very attractive for tourists. Sure thing, these formations do not only exist in Hawaii. Probably the most popular blowhole out there is located far away from Maui, in New South Wales, Australia. There's a small town of Kiama, and only around 15,000 people call it home. However, this small place attracts myriads of people because of a blowhole also nicknamed Kiama. This name has a meaning behind it. It's literally translated as where the sea makes a noise. And remember, blowholes are normally accompanied by a particular sound. The town of Kiama literally makes its living thanks to this unusual geological formation, attracting up to 900,000 tourists each year. There must be something special to see other than the hole, right? Otherwise, so many people wouldn't be ready to pay their hard-earned money to travel there. The blowhole in question can spray water up to 82 feet in the air. Trust me, if you come close to this place, you'll get thoroughly drenched in water. While this is not surprising, as we're dealing with the world's biggest blowhole here. Remember I told you, once you get into the blowhole, there's no coming back? It's not entirely true. Scott Gutterson actually ventured inside, studied the blowhole, and even found a secret chamber there. When he first went down to the bottom of Kiama, he found there a couple of bronze statues, some fishing rods, hats, a push bike, and even money. Still, you gotta remember that Mr. Gutterson is a professional, and you should never repeat his stunts. It's not the only blowhole that the town of Kiama has to offer. There's one called Little Blowhole, all because of its narrow shape. The good thing about it is that it's safer to visit than its big brother, but it can promise views as spectacular as the big blowhole. The brothers are a bit far away from each other though. The big one is just several feet away from the coastline, and the little one is around a mile south of the main blowhole. Sometimes there are fun legends behind those natural phenomena. You see, modern people can explain why water bursts from underneath the ground. We know the mechanics and logic behind it. But in olden times, people were way more superstitious, and it was not only easier to explain various phenomena as something supernatural, sometimes it was the only one explanation available due to the lack of knowledge and equipment. Thus, La Bufadora, a big blowhole in Mexico, got its beautiful legend. People used to believe that there was a whale trapped in the rocky point and that the whale would blow water to attract the attention of its pod. With time, the whale turned to stone and remained there forever. Nobody definitely believes in it in the 21st century, but this legend helps attract tourists from all over the world, which locals are very happy about. You see, La Bufadora is located in a small town 17 miles south of Ensenada, and the blowhole helps create working places. Locals opened souvenir and food places, and at some point, there were about 150 active businesses not far away from the famous blowhole. You can often hear that people call La Bufadora a marine geyser, and while some blowholes can be referred to this way, this is not the case with La Bufadora. This one lacks thermal sources, and thus it can't be called a geyser. The water sprout here is the result of air trapped in a sea cave and forced upward. For it to happen, a wave must push the air into the cave. As a result, this wave is released in the form of water, recedes, creating that signature spray going upward. By the way, those sprays can reach up to 100 feet into the air. The sprays have their own time frequency too. It depends on multiple factors. But as for La Bufadora, the range between eruptions is 13 to 17 seconds.
On January 14, 2022, residents of Anchorage, Alaska, heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research models showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions. Humans invest a lot of time and money exploring the unknown. First outer space, then the ocean floor. But there's another frontier we're trying to conquer. Scientists call it the deep frontier. I'm talking about how far down to the Earth's core we've made it so far. During the 60s, humans tried digging the deepest man-made hole on Earth. This took us deep into the Arctic Circle. What later became known as the super deep borehole is also the deepest artificial point on Earth, reaching the depth of 40,230 feet. It took 20 years to drill this far into the Earth's crust, and researchers say this is only about 1/3 of the way through to the mantle. Here's a quick anatomy of our planet. If the Earth is like an onion, the crust is like the thick skin of this onion. This part is only 25 miles thick. Beyond this is the 1,800-mile deep mantle, and after that, right at the center of the Earth, is the core, which is made up of 2 layers, inner and outer. Now, can you guess where on the planet the crust is at its thinnest? On the ocean floor. When American scientists understood that, they started drilling holes on the seabed. This gave way to Project Mohole. It began in 1961, but their technology to drill deep holes on the ocean was really bad. They had to improvise. They installed a system of propellers along the sides of their drill ship to keep it steady over the hole. The main challenge was to drill as vertically as possible. Otherwise, that deep hole would look more like a deep maze. Both the Kola Super Deep Borehole project and the Project Mohole came to an official stop in the years that followed. But hey, humans have built some pretty deep stuff underground. In 1963, a Turkish man took a swing with his sledgehammer to improve his basement and discovered a tunnel. That tunnel entrance led to more openings that connected a multitude of halls and chambers. He didn't know it, but he had discovered Derinkuyu. This once lost city was up to 18 stories tall and 200 feet deep. The city was large enough to host 20,000 people, and it was simply standing beneath Cappadocia in Turkey the whole time. Cappadocia hosts hundreds of subterranean dwellings. 40 of these underground cities are at least 2 stories high, but none of them are as huge as Derinkuyu. There's not a lot of historical accounts of how Derinkuyu was born. Some speculate that the oldest part of the complex was dug about 2000 BCE by the Hittites. The Hittites were an Indo-European civilization who formed one of the first major civilizations of the Bronze Age in West Asia. Scholars think they built this underground city to protect themselves from invasion. Others think it was actually the Christians who built the city in the 1st century CE. They speculate that it could have been constructed to protect people from the intense temperature variations, extreme heat in summer and freezing cold in winter. Geographically, the terrain under Cappadocia is great for building. The rocks are soft, which makes tunneling easier. For that same reason, opening large caves underground is fragile. That's why most chambers have pillars that support them. On the bright side, and we are, none of the floors at Derinkuyu have ever collapsed. The builders of Derinkuyu thought of everything. The city was shut off from the world by huge rocks that hid its entrance. It was ventilated by a total of more than 15,000 shafts, around 10 centimeters wide. This way, they guaranteed enough breathing air in the upper levels in a way that they ended up being used as the living and sleeping quarters. The lower levels of this impressive maze were mainly used for storage. But honestly, they had it all: a room for a wine press, for domestic animals, small religious buildings. They certainly didn't spare any efforts to make that underground city as complete as an above-ground one. Now, speaking of impressive underground stuff, Switzerland has the longest tunnel in the world, built here on the Swiss Alps. This absurdly huge tunnel was built over 8,000 feet below the surface. Check this out. This is what the Gotthard-based tunnel looks like. The first idea to build the tunnel was put forward as early as 1947, but construction only officially began in 1999. It took them years to approve the project and then scout for the perfect location. Even so, the 73 different rock types that compose Massif turned the construction into a real challenge. Some of the rocks were as hard as granite, and others were as soft as sandstone. This meant they needed different approaches and equipment so the whole thing wouldn't crumble down. Overall, they had to excavate about 28 million metric tons of rock to make way for the tunnel. There were many other challenges to build that far into the earth. The deeper into the mountain they got, the hotter the temperatures were. Since there's no natural ventilation, temperatures would get as high as 115 degrees Fahrenheit, making it really hard for workers to endure. The tunnel stretches for 35 miles from one end to the other. During the construction, workers had to use 4 massive tunnel boring machines, aka moles, to penetrate through the massif. Each of these moles was around 1,400 feet long. But that was one of the best things they could do, since these machines limit the disturbance to the surrounding ground and help to produce a smooth tunnel wall. You'd never guess that the world's deepest basement belongs to the Sydney Opera House in Australia. The building goes as deep underground as it grows above ground. But this basement isn't just the Opera House's foundation, it's a parking lot. This unique parking garage penetrates 120 feet underground, or 12 stories deep, while most car parks are only 4 or 5 stories deep. But that's not all that makes it unique. You see, if they decided to build a normal rectangular parking space, this would end up eliminating a bunch of possible parking spaces. And since they wanted to maximize the space they had available, they had to come up with some superb structure. First, they opened up a man-made cavern to make that dream possible. Then they had to come up with a design. That's what led to the donut-shaped cavern, or what engineers call a double helix. This design shocked the engineering community for its innovative approach. But hey, it worked! Today, there is space for over 1,000 cars down there, which seems about right for an opera house. Let's wow once again real quick. Some underground structures may take up to an hour to reach. Take this gold mine in South Africa that lies around 2.5 miles below the surface. Yeah, you may think, hey, it's just a couple of miles, why does it take an hour to get there? But the conditions are hard and it's not for the weak. But Milan Ladina, An Ecuadorian runner even completed a half marathon there, despite temperatures reaching 104 degrees Fahrenheit, high humidity at 80%, and an atmospheric pressure of 1.4, comparable to what divers experience 5 meters under the sea. Yikes.
The concrete of gigantic construction is cracking, barely keeping thousands of tons of water under control. That's when a tiny quake shakes the ground. It becomes a game changer. The old dam gives up. An enormous amount of water dashes through the rapidly growing ruptures, pressing on the crumbling wall of stone. Another moment, and the huge dam disappears among powerful waterfalls rushing toward the village down in the valley. When a large dam hits 50 years old, it reaches its alert age. But it's basically a warning that maintaining the dam is going to get much harder, and the risk factor starts going up. A recent study by the UN Institute for Water, Environment and Health discovered that the UK and Japan have the most dams in this alert age category. No wonder. In both countries, the average dam is over 100 years old. If you, like me, are wondering why so many dams are getting old at the same time, the answer is pretty simple. Back in the middle of the 20th century, there was a massive dam building boom. In the late 1950s through the 1970s, countries built over 1,100 dams every year. But after 1990, the construction frenzy slowed down. No more than 500 new dams appeared every year, and since 2000, this number has dropped even more, to below 300. But the huge problem is that many of the dams built during that mid-century boom are all aging at the same time, and a lot of countries are facing infrastructure problems at the moment. Because what happens when these dams get too old? If they're not maintained, they're likely to start to fail, and that's a real disaster, both for water supplies and safety. It's like a ginormous water-based game of Jenga. And like in the real thing, we need to make sure those pieces don't fall. A disaster like the one we're talking about happened to the Bancha Dam built in 1952. This structure collapsed in 1975 after catastrophic rains from Typhoon Nina, leading to the loss of up to 240,000 lives. One of the reasons was the dam's poor design. It wasn't built to withstand extreme conditions. So, when the region faced unprecedented downpours, the dam overflowed and collapsed. I bet you're now super eager to know whether that dam near your home is going to fail. Well, if you find it on our list of the world's most dangerous dams, maybe it's time to relocate. The Hoover Dam is one of the highest dams in the USA, standing on the Colorado River at the border between Nevada and Arizona. Towering at over 726 feet, it's a stunning sight, as well as a powerhouse of energy. Its base is as thick as 2 soccer fields are long, and each spillway can handle the volume of water that flows over Niagara Falls. But experts warn that if the gigantic Hoover Dam breaks down, it'll most likely lead to catastrophic consequences, putting millions of lives at risk. The problem is, the dam is getting old. Plus, it's located in a seismically active area. The Almendra Dam is the highest dam in Spain. It was constructed between 1963 and 1970, and its main purpose is to control the flow of the river Tormes. This dam is no joke. Just a small manipulation could unleash a wave of destruction, so it's actually a serious concern for those living downstream. The Jinping Dam, often referred to as the Jinping First Cascade, is the tallest dam in the world. Its height is 1,001 feet. You'll find it in China. It was constructed to regulate the flow of the Yellowstone River. This structure carries immense responsibility, producing between 16 and 18 billion kilowatt hours annually. The average US household consumes about 11,000 kilowatt hours per year. It means that the energy produced by the Jinping hydropower station is enough to supply around 1.6 million households. The Kariba Dam is a colossal structure built on the Zambezi River between Zambia and Zimbabwe, Multiple authorities carry out its maintenance, but according to reports, if repairs are not conducted as soon as possible, the dam could lead to terrible destruction in the surrounding regions. It's crucial to keep an eye on this giant. The Mosul Dam is one of the most dangerous dams in the world. It's constructed of loose mud instead of concrete. This design mishap has led to ongoing erosion. The mud gets washed away by the river slowly and steadily. People work around the clock to repair and maintain the dam, but it's still a crucial site of concern. The Idukki Dam, located in Kerala, India, is a magnificent double-curvature arch dam standing on the Periyar River. It's one of the highest arch dams in Asia, and it holds a huge volume of water. If a problem occurs at this dam, the consequences will be tragic for large areas. Such a disaster is likely to wipe out countless lives. So, the upkeep of the dam is crucial for everyone's safety. The Three Gorges Dam in China is one of the largest dams in the world and the world's biggest hydroelectric power station, completed in 2012. The dam is nearly 600 feet tall and stretches for 7,660 feet. That's more than half the width of Manhattan. The construction is so huge and powerful that experts say it's even had serious impacts on Earth itself. For example, affecting the rotation of our planet. However great it is, this dam poses a serious risk to the environment and safety. For one thing, it was built in an earthquake-prone area. Yikes. Plus, sediment buildup in the reservoir might make the construction less stable. Also, when they were building this dam, they had to relocate over 1 million people and significantly change the ecosystem. Famous for its beauty, the Monticello Dam in the USA attracts thousands of visitors each year. One of the reasons people are so eager to come there is its captivating glory hole. Indeed, at first sight, it may look like a picturesque feature. But in reality, this glory hole is actually a doorway to danger. It's basically a giant concrete funnel sticking up out of the dam. When the lake's surface level rises over 440 feet above sea level, which is close to overflowing the dam, the water starts draining out through the funnel as if from a bathtub. It creates a hypnotizing swirl, but you wouldn't want to get too close and get lost in the process. Nestled on the Columbia River in Washington, the Grand Coulee Dam has been powering the Pacific Northwest since 1942. It contains nearly 12 million cubic yards of concrete, which is enough to build a sidewalk 4 feet wide and 4 inches thick and wrap it twice around the equator. But this magnificent structure has some worries too. It's an aging structure, and at over 80 years old, it needs lots of TLC. It's located in a seismically active zone, which brings its stability into question. The Kurobe Dam in Japan is a stunning 610 feet tall. It was finished in 1963, so the structure is already pretty old. Japan's earthquakes makes this dam a bit nervous too. And last but not least, the area is prone to heavy rainfall. Intense rain might put extra pressure on the structure. On the Indus River, the Tarbela Dam is the largest earth-filled dam in the world. It was completed in 1976. Its issues include sediment buildup, which reduces its storage capacity. Plus, climate change has altered water flow, threatening the stability of the dam. The main reason we build dams is for irrigation. They help get water to our crops, and a whopping 40% of the food we eat around the globe depends on these big water-holding structures. Next on the list is hydropower. Dams are like giant batteries, turning flowing water into electricity. Then we have water supply, flood control, and even such fun activities as boating and fishing. But since dams are getting older, something needs to be done to protect people living close to them. The US is leading the way in something called dam removal, having taken down more than 1,200 dams in the last 30 years. Old dams are not only risky, but also expensive to maintain, so taking them down is often the smartest and cheapest move.
In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies will go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material. But in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, The event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
You probably saw a viral video where YouTubers hid a huge treasure in the Bermuda Triangle, and a random guy dared to go after it. He scored $10,000, but let's be real, his biggest win was getting out of there alive. This dangerous stretch of water between Florida, Puerto Rico, and Bermuda is notorious for its chilling and unexplained events. They say that more than 50 ships and 20 airplanes have mysteriously disappeared in the Bermuda Triangle. This leads to many theories, suggesting that this area is somehow linked to mystical powers or vortices that pull objects into other dimensions. But an Australian scientist named Karl Kruszelnicki might have actually cracked the code on the Bermuda Triangle mystery. According to him, most popular legends and eerie disappearances can be explained by two main factors. The first factor is human error. One theory debunked by Kruszelnicki was about the doomed Flight 19. Back in 1945, a group of 5 planes from the U.S. Navy took off on a routine training mission from Florida. Everything was going well until, 90 minutes into the flight, the troop commander reported that they were lost, and then, poof, they just disappeared. One of the largest air and sea searches in history was conducted to find them, but to this day, no one has found any trace of Flight 19 or the 14 men on board. What still makes people scratch their heads about this event is that the weather conditions when they took off were actually great. A relatively warm day, fluffy white clouds drifting across the sky, and a breezy wind coming from the southwest. Pretty standard for training flights, really, nothing out of the ordinary. So, what happened? It turns out that despite the flight leader having over 2,000 flying hours, he was a bad pilot. Actually, a really bad pilot. According to Krushelnyski, the commander was such a poor navigator that he had gotten lost at sea on at least 2 previous occasions before the Flight 19 incident. On that doomed day, he even tried to get someone to cover his shift but was unsuccessful, to the misfortune of his entire team. After their training flight exercise was completed successfully, both compasses on board stopped working. On the patrol's radio, his anxious voice said they were over land, or precisely, he was sure they were flying above the Florida Keys. But that didn't make any sense. He had made his scheduled pass over hens and chicken shoals in the Bahamas less than an hour earlier, but now he believed his plane had somehow drifted hundreds of miles off course and ended up in the Florida Keys. He couldn't have been more wrong. According to the most plausible theories about this case, what he thought was the Florida Keys was actually some small islands in the Bahamas. And here's where the real mess happened. Instead of turning back to the west, toward Florida, he kept flying east, deeper into the Atlantic Ocean. His plane eventually ran out of fuel, and you already know the rest of the story. Okay, some theorists might argue that a malevolent force somehow interfered with the 2 compasses, causing them to fail while they were flying this supposedly cursed stretch of water. But let's face it, even if that were true, human error was the main factor here. The pilot shouldn't have mistaken the Bahamas Islands for the Keys. End of that story. Now, let's talk about the second factor that, according to Krushelnyski, explains many of the strange disappearances in the Bermuda Triangle, and that's related to bad weather. A lot of Atlantic tropical storms and hurricanes actually pass right through the Bermuda Triangle. So, before we had advanced weather forecasting, these storms had caused a bunch of ships to go missing back in the day. On top of that, the Gulf Stream runs through the area too. That's a super strong ocean current that can make the weather change quickly and sometimes pretty dramatically. So, when you think about it, natural factors like these could explain many, if not most, of the disappearances. Take the USS Cyclops, for example. Back in 1918, this massive 500-foot cargo ship, carrying about 11,000 tons of manganese, just disappeared without a trace. It was sailing from the West Indies to Baltimore, with 309 people on board. What makes this event extra eerie is that not a single distress signal was sent. Over 100 years later, we still have no idea what happened to it. No wreckage has ever been found. Of course, people have come up with all kinds of theories about the USS Cyclops. One popular idea is that it ran into a sudden, violent storm. With all that heavy manganese on board, it might have capsized and sunk really fast. Others speculate about underwater events, like landslides or even a rogue wave. Now, this is not such a crazy theory if you think about it. According to Krushelnyski, the Bermuda Triangle isn't just a bad weather zone. It is about the raw power of the ocean itself. The ocean floor there is way deeper than most people realize, going down nearly 30,000 feet. That's basically like Mount Everest in reverse. When the ocean water gets that deep, it tends to hide things, making it the perfect place for ships and planes to just disappear without a trace. The expert confirms that there is also a tiny chance that even stranger events could be happening beneath the waves of the Bermuda Triangle, and that is related to methane clathrate. This is a fancy name for an ice-like compound that forms underwater or in really cold places with methane gas trapped inside. Sometimes these structures can break free, creating bubbles on the surface, and this bubble shower can be fatal, at least for ships. Some experiments done with model ships showed that if enough bubbles rise up, the water's density drops, and this can mess with the ship's ability to float. If a large number of bubbles come up and cover a large area quickly, the ship could lose enough buoyancy to sink or tip over. But to be fair, the chances of something like that happening are very remote. So, human error and bad weather. Those are the two factors that likely explain all the mysteries surrounding this so-called malevolent stretch of water. But the truth is, the Bermuda Triangle isn't all that special. Although this region is very popular, there are no official maps that clearly outline its exact boundaries and say, "Look, here, precisely, is the Bermuda Triangle." And that is part of the problem. Disappearances and unexplained events that happen far from the actual region end up being lumped into the Bermuda Triangle's list of unexplained mysteries, like the Mary Celeste's fate. In 1872, this ship was found completely intact, but with no sign of the captain, his family, or the crew. People thought, okay, creepy fact, ghost ship, so it must be related to the Bermuda Triangle. But one thing doesn't add up. The Mary Celeste was abandoned about 400 miles east of the Azores, so we're talking about a completely different part of the Atlantic. By this time, the triangle has morphed into a trapezoid to cover that huge chunk of the North Atlantic. What I'm trying to say here is that once people start believing in a danger zone, confirmation bias takes over. But the facts are that the Bermuda Triangle sees tons of daily traffic every single day, both by sea and air. And according to experts, the number of incidents that happen there is pretty much the same as anywhere else in the world, percentage-wise. Some years the number is a bit higher, some years lower, but it averages out the same. With that in mind, it seems like it's time for us to finally move on from wild theories involving the Bermuda Triangle. Well, at least until the next bizarre disappearance comes along.
There's nothing around, just the eternal, endless whiteness of Greenland's snow and cold winds blowing into your face. Nothing hints at the impending catastrophe. You take another step and freeze in horror. An abyss is spreading at your feet, bottomless and dark. If you had made a bigger step, it would have swallowed you. That infamous Greenland's hole. It happened in the middle of the 2010s. A group of geologists were scanning the surface of Greenland's Hiawatha Glacier using radar when they spotted something very, very strange. It was a giant pit, more than 980 feet deep and almost 20 miles wide. That's big enough to fit inside Washington, D.C. or Paris. After staring at their radars for quite a while and scratching their heads, researchers decided to find out what could have made such a huge hole. Could it have been good old erosion? A raging volcano? An asteroid impact? A giant sandworm? Ugh, I might have gone a bit overboard with this worm idea, but you never know with these ancient glaciers. Anyway, in our case, one mystery seemed to lead to another, which had been puzzling scientists for decades. And to solve both of them, scientists needed something super common, but at the same time very important: quartz. One of the most abundant materials in Earth's crust. But before we dig deeper into this topic, let's make a small detour and talk about a pretty bizarre phenomenon called the Younger Dryas event. To see what it was like, we need to go deep into the past, as far back as 12,900 to 11,600 years ago. During that period, the planet became much colder, especially in Europe and North America. Now, let's talk a bit more about that weird climate change in the Northern Hemisphere. There are a few theories. One that involves a change in currents in the Atlantic Ocean. Another speaks about something large kicking tons of dust into the air and effectively blocking sunlight. The two most popular and likely hypotheses mention a volcanic eruption and an asteroid impact. Indeed, there was a volcanic eruption on the territory of modern-day Germany at around the right time. But there's also a probability that a space object struck the planet during this period too. And now let's get back to the hole scientists found in Greenland. When NASA's Ice Bridge program and Germany's Alfred Wegener Institute discovered it, it seemed they had finally found the reason for the Younger Dryas event. But was it really an asteroid that created that impressive pit and caused temperatures to drop all over the Northern Hemisphere? To test this theory, the researchers needed quartz. The thing is, in its pure form, quartz has a very simple structure. It's made from interlocking silicon-oxygen tetrahedra. Efficient and so pretty. Just look at these six-sided prismatic crystals. Since its structure is so simple and the components are so common, you can find quartz almost in any rock on the planet. At one point, magic happens. Larger rocks erode away, pushing out tiny bits of quartz sand. The scientists exploring the mysterious pit gathered the quartz sand that had been washed out from underneath a glacier. It was like looking at the rocks at the very bottom of the hole without having to actually get all the way down there. Very handy. So, while examining the material, they discovered quartz grains with the telltale signs of terrible catastrophe. They had PDFs all over them. No, I'm not talking about the document format. PDFs stand for planar deformation features, and they look like lines etched into the crystal surface. These lines are a sign that you're holding shocked quartz. It forms under immense pressure, when the internal crystals are pushed out of alignment. But the most exciting thing here is that shocked quartz only appears under the influence of powerful forces, like massive impacts or terrifying explosions. In other words, finding this poor shocked quartz under the Hiawatha Glacier could be much needed proof that the hole was an enormous impact crater that formed when something equally enormous crash-landed there. Based on the size of the crater, this space object probably was a bit more than a mile across, which is twice the height of the Burj Khalifa Tower in Dubai. A meteorite that big would have looked 3 times as bright as the sun when traveling across the sky, and it would have hit Earth with an immense force. The impact would have been so great it'd have vaporized rock and thrown debris for hundreds of miles away. The sky would have filled with dust. It would have dimmed the sun and led to a temperature drop all over the planet. And guess what? The last part about decreasing temperatures got the researchers super excited, because it opened up a possibility that the impact could have been connected to the Younger Dryas event. To prove this idea, scientists decided to use quartz again. They examined it more closely, trying to date the impact. Well, they were in for an even greater shock. The Hiawatha crater turned out to be not 12,000, but 58 million years old. On the other hand, the researchers were disappointed that they hadn't been able to confirm their theory. The crater couldn't explain the Younger Dryas cold snap, but on the other hand, it was still an amazing discovery. Now, get ready for one final twist to this story, and it revolves around quartz again. Other scientists have recently discovered more deposits of shocked quartz all over what is now the eastern USA. It was hiding in sediment layers dating to just before the Younger Dryas. Interestingly, there aren't any craters around those sites whatsoever. But quartz can't lie. It provides evidence of a powerful explosion. It makes scientists think that their impact hypothesis might still be true, but instead of a collision, it could be an airburst. A massive comet could have broken up while entering Earth's atmosphere around 12,000 years ago, and the fragments could have exploded before reaching the ground. It would have caused catastrophic mass burning throughout the North American continent and messed with the climate so much that the Younger Dryas would have been triggered. Well, I guess we need to wait a bit longer for scientists to find some further proof of this hypothesis. But it doesn't mean we don't have any more curious phenomena to explore in Greenland. Take these fascinating holes. They sure are kinda smaller than the monster we were talking about. They're called moulins, and they carry surface meltwater all the way down to the base of the Greenland ice sheet. And they have prepared some surprises for us too. Apparently, they're way larger than we previously thought. That's what a recent study based on observation and first-hand exploration claims. Even more interesting, this high volume might influence the stability of the ginormous ice sheet in question, as well as the speed at which it's sliding towards the sea. Researchers think that increased water depth and pressure inside moulins might lubricate the base of the ice sheet, making it move faster. You know, the way an ice cube slides more easily on a thin film of melted water. Until recently, we knew too little about the real size of moulins and how much water they can hold. But now, we know that moulins can be giant. The team made 2 trips to the Greenland ice sheet in 2018 and 2019. And during each of them, they used ropes and climbing equipment to drop around 330 feet into 2 separate moulins, almost touching the water's surface. Those who did it described the experience as intimidating. Picture this. Your back is over the edge. All you see is bluish ice going down and blurring into blackness. And the only thing you hear is occasional sounds of crashing ice. It must be extremely unnerving.